Hello, my name is Rachel, and I'm here to talk about numbers, specifically integers, floating point numbers, and Boolean types. These number types are used in nearly all computer programs, and a master programmer needs to understand their uses and their limitations. Let's get started. Let's first look at whole numbers. Whole numbers are those numbers with no fractional component. 5 is a whole number, but 5.1 is not. Oh, and by the way, whole numbers must be positive. Using our previous example, 5 is a whole number, but negative 5 is not. Whole numbers are not used in programming, but integers are. Integers are simply a more refined version of whole numbers. Integers are simply whole numbers that include 0 and negative numbers. Integers are still whole numbers because there is no fractional value, no decimal point. Think of a number line. You can count up, you can count down, and there is a consistent gap between the numbers. Integers are excellent for counting items. For example, we can count fruit or sheep, but it would be silly to try and count negative sheep. However, some items, such as temperatures, requires us to count below 0. My husband grew up in Minnesota, where the winters would get to negative 40 degrees Fahrenheit. I don't know about you, but count me out. In programming, integers are also frequently used for counting. A programmer may need to know how many times a letter on a keyboard was pressed, or how many times a user tried a password. Bottom line, the uses for integers in programming are endless, and you will encounter them often. Remember, integers are whole numbers that include negative and positive numbers. Integers have no fractional component, no decimal point. Let's now look at numbers that do have a fractional component represented by a decimal point. Computer programmers call decimal point numbers floating point numbers. The detailed history of this reasoning is beyond the scope of this class, but basically it has to do with the way the numbers are stored in the computer's RAM. In the RAM, the decimal point can float to different positions within the number. For example, when the number 123.505 is multiplied by 10, the answer is a simple movement of the decimal point to show the answer of 1235.05. If we then divide this number 100, the decimal point floats to show the answer as 12.3505. The actual sequence of numbers never changes. The decimal point just floats. Let me now introduce 3 terms related to floating point numbers: overflow, underflow, and rounding errors. Overflow and underflow conditions occur when there is not enough RAM to store the very large or very small number. When this happens, the program will generally crash. A rounding error occurs when there is not enough memory to store the number accurately. The program will not fail, but your calculations will not be accurate. For instance, let's say the RAM in the computer you wrote your program code can only store 2 decimal places. We could have problems with accuracy. Take the number when 1 is divided by 100. The result would be 0.01, an accurate answer. However, if we increase the amount of RAM in the computer, or if our program is run by a machine with more RAM, the answer could be 0.010001, an inaccurate answer. This difference is due to the way the numbers are stored in the binary language of computers. Speaking of binary numbers, this brings us to another type of number used in programming: Boolean values. Boolean values stem from early electronics, where an electrical component either had electricity or it did not. Electricians started calling the electrical condition either a 1 or a 0. The number 1 is considered true, and the number 0 is considered false. Boolean values are typically used by programmers so the program they are writing can make a decision. For instance, a program may ask a user if they want to continue with running the program. If the user presses the Q key on the keyboard, this would result in a Boolean value of 1, also known as true, which then sends instructions for the program to end. It's that simple. I have presented to you 3 types of numbers that you will use in the programs you will write for this course: integers, which are whole numbers, positive or negative, including the number 0, floating point numbers, positive or negative numbers with a decimal point, and Boolean values, a 1 or a 0, an indicator of true or false. Your understanding of these numerical types are critical to your success as a programmer. I hope you will have a great day. Goodbye.